How's it going, everyone? Eulero Gonzalez here again, and in today's we're gonna talk about is the hard part of the JavaScript, the async nature, specifically iterators, so we can move on to the generators as a way to understand what is this async and await keyword is doing behind the scenes. So this is one of the beautiful things from this course, which is taught by Will Sentence, the CEO of CodeSmith, a software engineering and machine learning residency headquarters in New York and California, where in this particular course, we're looking at this new EX6 and 7 features so we can know how asynchronicity plays in JavaScript, as well as how can we now think this new way of accessing data. How can we now have control over the data using generators, and how when you combine these two concepts to make sense of this keyword called async and await. So with that, now will give us is a more precise understanding of how this new concept works behind the scenes. So especially as the reason of recording this series of videos is to improve my communication skills, and particularly this set of lists that we got here. First is the analytical skills in real time. How is your thinking process? Then your technical communication. Based on your approach, can I implement your solutions? So can I implement your solutions based on your explanations? Very, very important, especially if you want to now scale that up into more senior roles. And that's something interesting, because at the beginning you need to learn a small set of skills, and then as you're starting to face new and more complex challenge, not only your profession but also in your personal life, you need to dedicate time to know how you're going to learn those skills, particularly the technical communication skills, as well as, well, following is a good engineering practice, like continue reading to understand these new trends, and the documentation, as well as the soft skills. So if you're empathetic with someone, if you're empathic with someone, or how much patience do you have when you have to explain you with someone else, your solutions, your approach. And lastly is the domain-specific knowledge, which is the language and the computer science experience. So with that, all right, the course of this asynchronicity and how it plays on JavaScript is laid out in first. We need to understand is the fundamental of JavaScript, okay, this introduction, and then how now JavaScript works, the asynchronicity works in JavaScript, so we can now understand what is the value proposition of promise. And to understand now this new syntax, async and await, we need to look at two particular concepts: iterators and generators. All right, so right now we're going to, in today's video, we're going to take a look at the iterators, as well as put a practice how we're going to build our own iterators. But first things first is this introductions, the JavaScript fundamentals. JavaScript is made of the thread of execution. It evaluates line of one line at a time. Okay. It also has the variable environment, where it can be global or it can be in a function. Okay, where inside of the function, anytime JavaScript evaluates that, it creates a function execution context. So you have now the thread of execution, the global variable environment, the function execution, which itself contains the function thread of execution, as well as the functions variable environment. Okay. We also have now the ability to keep track of which line of code we are currently at, and that is the call stack, right? And then we now have is a nice little feature that is relevant to JavaScript called closure. When you return a function from another function, which now it allows this new function returning to access to the outer lexical scope, to access to the outer variables and function that was defined outside of this. Something that is very, very useful, especially when you want to define is once, function that runs once. So for example, if you're in a game, after you finish that, you want to show this congratulations. Then you got it. That congratulations was not good, man. That was terrible. That celebration. Anyway, so that's what you want to do. Or, for example, memorize. So with memorize, you have now the ability to, instead of recalculating something that you have previously done, you just return as a result. So for example, not only in Fibonacci sequence, which is something that is heavy to compute, but let's go to make something more simpler, like multiplication tables. So if I ask you, how much is 9 times 9? It takes quite a bit of time to actually do that. 81 is the result. So the next time I ask for this, you already know that. That's memoization. Again, memoization is a technique in the computer science to store computational, to save computational power, to save time spent of computing something. So that's great. Totally. So now that we know that, okay, and we also know how to evaluate that looking at diagram like this. Yeah, we didn't put any of the diagrams like this. Now we went is to look at the asynchronous nature in JavaScript. So how do things plays out? Well, because after all, JavaScript is a single thread language, so it means that it doesn't deal with any of this asynchronicity stuff. And because JavaScript runs in a particular environment, whether it's on the browser or on the node, unlike other language, like for example C, Ruby, Python, where now the environment that they run is the OS. Okay, so because of that, this environment most exposed is facade functions as a way to allow them to do this asynchronicity. And one of these facade functions is called timers. Okay, so for example, with set timeout here, we can now defer tasks that will be complete sometimes in the future, or tasks that I want you to do sometimes in the future. Okay, so the way we do it here is by using the set timeout or any of these timer functions that allows to do that. So we pass as a function reference to the set timeout, followed by the milliseconds, all right? And once that time is done, because here after all you're calling is this facade function, once that time is over, so now the browser hold this reference, and you may wonder what is the next thing. So yeah, it has this reference, but how now the browser or the server communicate to the JavaScript land to actually, well, receive this function, and then process that. So that's what we have is the callback queue, okay, that live inside of the host environment, which is something interesting. In the in the event loop, which is this mechanism that say, hey, you know what? Yeah, let's take a look at the callback queue, okay? And if the call stack is empty, which means that in JavaScript land we evaluate all of our statements, okay? Now we can grab whatever we got on the callback queue and put it on the call stack. So JavaScript know, hey, I got something in the call stack. I got something to evaluate. Let me take a look at this. He evaluate. So once he evaluate that function, then he pop up out of the call stack. And this process is something that once you understand, fairly simple. It's very, very straightforward. Now, the thing here is that because what happens if you want to, when you need data that depends on other callbacks, or when you need data that depend on other tasks that will be completed on the future, but you don't have them available. You have to wait for that data to be available, and then is when you can now have access to that. And if you need to do another async test, you have to do the same for that. So you may wonder, what is that? Why we need to actually do that? The problems with that particular approach, okay, for example, when you have nested set timeout, okay, wait for, like that, is that not only makes your code much more verbose. Let me put it here, an example here. The ambient async callback, right? Callback function, exactly, using the timers, like so. Okay, so not only that, is not only that, exactly, it's not only that, okay, deferral timeout, okay, this is working with set timeout. So this is now explaining is that what happened when you want to use is that this value instead of a set timeout. And because by that time now that function has been passed down to that, the value of this or the data that you want to work is not there, it's not relevant. So that's why they say, hey, you should be using is well, or a function or an arrow function, or use a bind to set the value of this for all calls and given function. So for example here, right? So anytime, because here you are now bind this at definition, not at runtime, which means that now you will have access to that context, to the value of this. So this is something interesting actually in JavaScript. But in any case, our point here is to demonstrate async function here, asynchronicity in JavaScript. Okay, like this. So introducing asynchronous JavaScript here. Wait, what? Like so. Get user media is also a promise as well. Exactly, it's a way to access to that. Show open file picker. Okay. Exactly. So for example, things like this. So exactly, this is to if you want to catch this data, which is something that we're going to describe that, but the idea here is to look interesting. Okay, but this is the eloquent here. Well, actually, this is explaining is one of the reasons of this, right? So, for example, because with callbacks, we can now define in here something like this. Okay, in our callbacks, we can say, hey, const wait for, all right, and we define is an arrow function here. What we're going to receive is our callback function. Okay, and I want you now to, after a specific amount of time, run the callback after, let's say, 500, right? Or if you want to set this like this, say timer, as a way to now have much finer control of what's going on. Okay, so far so good, because we can say is hey, wait for and we pass our function, let's say here, let's say here for demo purpose, this will be is, remember that this is a callback. They say, hey, I want you to console log a callback, and we're gonna define is the timer here. Callback data after 1 millisecond, 1 second, right? And the second parameter we pass is the 1000 seconds. Okay, so far so good, right? And then we get the data. So that's right, that's good. But what happened if we need to also define and not if we depend of this data to be completed, okay, to access to now inner functions. So for example, wait for here, and when you say, hey, I want you to now do this as it is, right? So as you can quickly see here, we are now need to nest another function here. You know, no, come on, for real, Jesus. So wait for, and then you pass a callback here, followed by its own timer. Okay, followed by its own timer, and this one. So not only that, you are calling that callback every 1,000 seconds, okay? But you effectively are creating is a loop for them. So why this is important? Okay. Really? That's quite interesting. Okay, let me take a look now. The GitHub. No, but this is on Node. No, okay. That's right. Yeah, because what I'm doing is just cloning is this repo. just to show is this particular example here. Because it's that. So the idea here is to say, hey, because if we want to defer tasks that will take long time to complete. So for example, let's go to define is our counts here. We say wait for as an arrow function, and here we say, hey, I want you to receive is the callback, okay, followed by the timer, okay, and here I want you now to okay, exactly. I want you to now evaluate this. Do not return this. I want you to evaluate this, which is set timeout with the callback followed by the timer, and that's it. Pretty much that's it. Pretty much that's it. But because this callback must be a function, okay, because this callback must be a function, we need to return this as a function here, okay. So we need to say, hey, this is the function that I want you to run this, and I want you to return that. So once you're able to do okay, let's do that again. So the idea here is to say, let's go to define is now a function, an async function, wait for, right, where you say, let me now accept some parameters from this function, like the callback and the timer, okay, and here is we're going to create is a new execution context that I want you to evaluate JavaScript is this statement, this vacate function, that because this vacate function say, hey, I need is a callback, okay, we can pass this callback as it is. So this callback must return something. This callback that we are here must return something, and that's what happened here. So because this callback must return something, and if we let the user to define that this is a callback that we want to return, what happened is that if we not held the if we're not explicit about how we're going to pass this function, okay, the set timeout will then do some nasty things. So in other words, you want us to do something like this. Hey, this is the function that I want you to pass. This is this arrow function callback here. And again, this arrow function, what is doing behind the scene is to create is a closure. Something that we're going to see that later. So this is the arrow function here, as well as the timer. So far so good, right? So for example, what if we want to now say, hey, wait for, and I want you to now evaluate this function that I'm going to pass you here. You say, hey, console log, wait for 100 milliseconds, right? You know, you can say, hey, come on, wait for 100 milliseconds, and then we're going to pass these milliseconds here, right? So this actually will work as expected. After 1 millisecond, he will actually run that function. Hmm. Oh, because we never. What happened here is that we never is execute that. We just pass is the function. And what happened is that we need to run this callback here. Okay, okay, okay. Again, this is the way how now set timeout specifically works. Let's do that again. So we're going to define now is a function here called wait for that will take is the callback followed by the timer, okay? And because we are creating is an arrow function, the value of this will be whatever it create a closure around this. So here I want us to now evaluate this key function called timers from the web API, okay? And because this timers set timeout, because this timer here, because this timer set timeout global function, because this timer need is a function reference, okay? A function to be executed after time expires. Because this function require is a function reference, okay, which means that what is the function that I want you to run? Well, we can do is something like this. I want you to now run this function, the callback function that I get from this. Okay, so this is our function that we're passing here. So if we define this, if we define this, for example, and then we pass this our timer, what happened here is that anytime we call, for example, wait for, and we pass now a callback here like this to say, hey, I want you to now printer here is 100 second. So here, because we are passing this function reference, and after that times I want you to evaluate this, it'll do that as, but it do that immediately. You know what I mean? Because CB exactly, it's evaluating that, and we're not even passing the timer properly. That's interesting, because even though that we're passing the proper timer here, so no matter how many we are now calling this function here first. That's what happened with this. Okay, that's what happened with this. At the end of the day, it's calling that immediately, because this is the behavior that, okay, this is the behavior that have the browser. This is the behavior that the browser has, and it expects you to have is a callback here. Because it creates now a new run execution context. That's interesting. However, if we, for example, pass only the reference, then he's going to evaluate that. Exactly, because after all, it needs the reference, my friend. After all, it needs is the reference, the function reference. So if for some reason we want now to pass is another function here, like so, all right, when we want to now evaluate is when we want now to evaluate is wait for, again, when we're gonna pass this, we're gonna say 1, which is on 2 milliseconds. It's actually work as expected. Okay. Ooh, and we're back. And we're back. So as you can see here, okay, we can even nested function inside of this, okay, and say, hey, now I want you to defer this particular task, okay, to be completed sometimes in the future. So I want you now, instead of doing this, I want you to now also is add a new asynchronous task, which is wait for this. Okay, and first we're gonna pass this callback function, and then the timer. Okay, okay, and here finally when we're gonna say, hey, after we are done with this, I want you to now is, so after we wait all of this time from all of these other async tasks, okay, now I finally want to get the data. And there you got it. One of the problems with this particular approach, remember that after all it needs a timer. As you can see, one of the problems with this approach is that it makes our code verbose. And I want to define is this. Okay. And I want to define with this. It makes our code verbose. For example, like this. Let me in fact grab this. Wait with callback. Okay, this is wait with callback. It's not only that, but this is what we know as the, this is what is known as the pyramid of doom, right? So if we need have all of this data that depends from another, okay, so you can quickly see how lengthy and verbose it is, and it is hard to read. So now with this particular approach, okay, especially here, with the promise here, that's right, with the promise, I think we already got that, yeah. But now with the promise approach, or how you can promisify as async task, for example, by saying, hey, it's going to define now is wait for the promise, or wait with promise, that the way of how you can do that is by saying, okay, let me now return here a new promise object with a timer here, okay, which we're gonna say this. We're going to create is a new promise object, and for that we need to use the new keyword, which is part of the ES6 syntax, that what it's doing behind the scene is to set the value, particularly with the promise, is create an object on the JavaScript that has is the value and unfulfilled and unreject, okay? So the value will be something that now when you get now when you get now that value, it'll be updated to this object, okay? And when that time has passed, this is the callback, this is the function unsuccessful that I want you to run. So on resolve, this is the function that I want you to resolve. Or on reject, this is the function that I want you to run, okay? So because here, this is now a function like this, because after all we want is to return is this new object. I want you now to evaluate is this. say, hey, wait for, where here we're going to pass this timer, okay, with the resolve, okay, which is the callback that I want you to run, okay, after the timer. That's it. That's it. Right? That's it. So, with this, okay, now we can say wait with promise, and because we are getting because here we're getting is a promise, this promise now has a property called .then that allows it to pass the callbacks when that has been resolved. Okay, so one of the great things of this is we can say, hey, let's gonna put it this .then, is this, and now this is the callback that I want you to evaluate. Okay, here, which is the console log. All right. So first, I want you to do is this. Yeah, the first promise, let's say we're going to take 1 second for that. We are now indicating is how much this should take. Let's say 2 seconds. Okay, .then, all right. We can now say is 2 seconds has passed, right? So this is the first promise. The first promise, 2 seconds has passed. And when that time has passed, okay, I want you now to return is to perform is, now that I get this data, I want you to now run in the next, I want you to pass them to the next callback. I want you to now make it easy for the next callback to work with that data. That's what I say. We're going to return here now is a wait for here, where wait for is actually now, yeah, where wait for is now, or I mean wait with promise, exactly. It's wait with promise, where now this is expected, because we're creating is a promise to be run after 1 second. Now we can change the results of that. Okay, so after that 1 second here, you want us to now say, hey, this is now our second promise, as it is second promise, which is 1 second. We have wait for that, or in total, second promise, total time 3 seconds. Okay, and as you can see here, we can is after that. Okay, so after now this will, after that we wait for this function to be, so after that we wait for this time to be completed, not only in a timer but also in other async operations. So for example, network operations, or read a file in your computer. Okay, so wait for other servers to complete that they wait for a database to respond, wait for another service to respond, or wait for reading this particular file, whether it's a text files or an audio or video, okay? And then I want you to return now with a promise, okay? We can say, is this promise here? Return new promise, okay? Which is actually going to behave the same. But to be less verbose, we're going to say wait with promise with another second, and we can change that again. As it is. When you say, hey, console.log here, this is now the third promise. And this is total time 4 seconds. No, yeah, I get it. Oh, is this one as well? Okay. Anything, that's it. Exactly, anything, that's it. Yeah, but there is some I think I'm missing something here. Wait with promise. Oh, I think, okay, it's this one because it's here. Okay, so after that, you say the second. Oh, reference error. Wait with promise. Yeah, and after that, I want you to return is this. Where we promise is not defined. No, that's good. We don't, because I don't want to. You run it the first time. Oh, because I human errors, as always. Human errors. Exactly. Human errors. So now here, okay, it say hey, and that's it. So that's one of the great things of the subtle difference between now using is this particular approach okay, is using now this particular approach now with promise. Okay, so anytime we are get the data, we're going to return is a new promise here as a way to change that data, so we can have now access to the data from other or from previous asynchronous task. That's the whole point of this. Until you finally use is just this await and async for that. So that's what we got is this. Wait with promises. Wait with promises because I misspelled that. Exactly. Again, this actually works because at the global, now it await or it make this async operations. You know, any promise here, it makes now wait for that. So it's something that we're gonna see how this actually keyword works. But again, the entire reason of looking at this is as a way to now understand how JavaScript works behind the scene, and when you need to explain it to someone else, so before going into the async and await, we need to understand exactly how promise works, how promises works behind the scenes. Okay, so before going into async and await, we need to understand how promises work behind the scenes. Okay, exactly how promises work behind the scenes, iterators and generators, as a way to understand all of this inner mechanism. So let's get into that. So that's exactly what we did here with promises. Okay, as a way to describe what promise is doing, this particular ES syntax, ES6 syntax, where we can now is make our code much more readable. Why is that? Because most of the time, I will argue that 90% of our time is just to read code. That's all. 90% of our time, especially when you are here, is reading code. And because of that, improve that readability is something that is valuable. So what happened here is that this is interesting because it's now explaining some of these solutions here. It's explaining these solutions here. It's explaining these solutions here. Users can do nothing here. Could be 300 milliseconds, could be half a second. Okay. Now it makes a lot of sense. Okay, now it makes a lot of sense by looking at these particular solutions here. Okay. Interesting. Okay, interesting. Very, 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 very interesting. Exactly. Now this is explaining here how to then handle here. Exactly, in a way that looked like synchronous. Exactly, it's not explaining it's the event loops and that kind of thing. Asynchronous box. So, yeah. It's like, yeah. So that overview, it was so that huge introduction, it was just as a way to describe how now asynchronicity works and how do we get here. Because once you understand that, you will embrace complexity. And especially here with our promise here, where now the promise with this solution 3, instead of using await and callback, especially if you want to now perform tasks that will complete sometimes in the future, okay, it is important to understand how this promise works. What is the value proposition of promise? And if you take a look at the specifications, it tells you that this promise, which is an object, represents the eventual completions of a async task, whether it is successful or rejected. So because of this, now promise create this object here on JavaScript that contain is, in fact, we can take a look now at here, ECMA here, specification, that's right. As a way to look at the promise object, okay, the promise object here, which is control abstractions objects, the promise object here, that it has now methods like promise, which is an object here, resolve and reject, which will be passed down to that. So when this function for some reason is being rejected, okay, this is what you want to do. If you reject it, if it is resolved, this is what you want to do. So even though it doesn't tell you what is this, the shape of this promise object here, you know, let's find out. If approved, rejected, promise reaction record, create resolving function, fulfill promise, new promise capability, is promise, reject promise, trigger, that kind of thing. The promise constructor. The property of the promise constructor, property of the promise prototype object. Okay. Exactly. Promise of the prototype object. So now this promise object, okay, property of the promise instance. Okay. So the promise object first, it described is the, as well as the iteration, iterable, and iterable, control abstract operations. That's interesting. Control abstract operations. Okay. Control abstract operations. That's control abstract operations. Okay. Control abstract operations, structured data, managing memory, control abstract operations, reflections, memory model, promise object, the global object. I just want to take a look at, just for demo purpose here, is the source lexical grammar, expression, statement, functions and classes, script and models, error handling and language extension, ECMAScript standards, built-in objects, the global objects, fundamental objects, numbers, date, text processing, indexes collection, key collections, structured data, managing memory, and then you got reflections, memory model. Okay, but this is now control abstract object. Control. Let me take a look now at the control here. Control Abstract operations, type conversion, testing operations, and operations on iterator objects. ECMAScript data types, notations and conventions. Okay. Web scripting, host and implementation, and that kind of thing. Notations and conventions, ECMAScript data types, abstract operations. Okay. But that's quite interesting. Based on this specification, executable code and execution context. Exactly. Processing model. So it's like now reading at the specifications, you can make sense of what's going on here. Fundamental objects, numbers and text processing, and control abstract objects. That's quite interesting. Control abstract objects. Iteration. So is iteration promise? So they are control abstract objects. Iterators, promise and objects, promise jobs. Generator function objects like this. Async generator functions. Generator objects. Interesting. Generator objects. Property of the generator instance. Generator state, generator context, and generator brand. Async generator objects. Property of the generator instance. And async function objects. And async function instance. Length and name. Async block star. Promise capability. Async body and async context. Okay. And await. Okay. We're not going to dive deep too much here. We just only want to know is what is this promise object that JavaScript create for us that represents the eventual completion of an asynchronous task. Okay, so because this is an object, okay, especially here is promise, reject promise, is trigger promise rejections, is promise abstract operations, the promise, the property of the promise instance like this. So now the shape of this object that is created is, it has a hidden property called promise states, okay, that whether it's pending, fulfilled, or rejected, okay, govern how a promise will react to incoming calls to its then methods. So because now we're making sense of how can we make this how can we use promise with the fetch function. Again, this is a facade function that allows us to perform async tasks to the from the browser. Okay, to perform is to make requests to other servers across the internet. This facade function. And in the case of now, we have this real file sync or read files, okay, that allows us to now access to the files. So because of this two facade function, okay, JavaScript will create this object in the JavaScript. Okay, that this object has, well, the state that represents the pending, fulfilled, or rejected. So based on this, it will now define which callback functions you're going to run. So the promise results is where you have now the value, this hidden property, is where you have now the value with which the promise object has been fulfilled or rejected, if any. Only meaningful if promise state is not pending. So you're gonna have is the value of this, okay? And again, you may wonder how does it work? It's like, who is responsible for actually notify this object that this changed? If you're using set timeout, this is when you set the timer. If you're using Fetch API, this is the browser or Node. If you're using readsync to read a file from Node specific, it's Node that is doing that. So that's quite interesting, because now here with promise, we are dealing in the realm of JavaScript as well as in the browser or Node. Okay, so first, the promise object create this object to represent is the eventual completion of a task. Makes sense. Makes completely sense. So depend on which task you want to perform, whether it's to read a file in Node or to make a request. Okay, this is now how you can communicate to the underlying environment as a way to now, when that value is done, the host, the environment, will notify to JavaScript, hey, we update this value, okay? And if this value now has a particular state fulfilled, I want you now to run all of the function that we define is on the unfulfilled, okay? The promise fulfilled reactions, a list of promise reaction records, okay? But if it's not, then I want you to now run is the rejected functions. Why this is important to know, okay? And you may wonder, okay, but who is responsible for calling those functions? Now here is when the way how that works behind the scenes, the way how now these hosts notify the the JavaScript about that this task, that we get the proper value, whether it's that we update the state, and if that state is fulfilled, hey, this is the function that we want you to run, okay, on rejected or unfulfilled. So I'm going to add those functions to this queue called micro task, which has higher priority than the callback. And I think this is something powerful. This is something beautiful. Why is that? Because now JavaScript designers, okay, so now JavaScript designers say, okay, now that all of this makes sense as a way to see how all of this inner mechanism works, it is time for us to define some couple rules here that govern is promise, especially the micro tasks that communicate with the event loop. So it's constantly checking if the call stack is empty. Now it's going to grab is all of the promise here, So all of the task or callback functions on the micro task queue, and it's going to get that all of them until it is empty. So you have to be careful here, because the problem with that is if you continuously add or keep adding tasks to that, okay, it will never reach to the callback queue, so you will never so you eventually are now having an endless operations in the micro task queue, and that's not good. That's not good. The TLDR of all of this, because it's like lengthy and verbose, and also as a way for us to look at the specification and say, hey, take a look at the promise, take a look at the property of the promise instance, okay, as a way to make sense of that, similar to here in MVN docs. When you say promise, even though that is trying to explain that how this is work, but by looking at how this mechanism actually works, it's like pretty much compelling. One of the things of this is that now you can handle with promise. You have much more fine control when it comes to handle rejection, when it comes to handle this errors. Okay, so all of this was to describe briefly is the asynchronous nature, put a practice of what I have learned so far. As a way to describe is the how asynchronicity works in JavaScript by use, and how by looking that our code doesn't actually work as expected, which is line after the another, especially in the async work. So that's where we use these vacay functions called set timeout that allow us is to defer task sometimes in the future, okay, and get that. The problem with this approach is that even though that once you understand that how that works, well, yeah, even though that you understand that how that works, it is lengthy and verbose. So for example, here, okay, because especially once you define task, async task that depends on previous task, so now you have all of this, which is something called as the pyramid of doom. So now the JavaScript designer say, hey, wouldn't it be better to have a more cleaner, readable way to do this, okay? And that is with promise. So now promise is this new ES6 syntax that allow us to write this asynchronous code that look like pretty much like that improve readability, in our code. Okay, so now that we look at how that works behind the scenes, okay, and especially how you can make that work with set timeout or this callback, as well as with vacay function like fetch, okay, and understand that after all, this is a promise, that this is an object that is created in JavaScript that have is state or pending state, that is fulfill, reject, or pending, and depend and when that value is done, when that state change is done, it's going to update another property called the value, which is a hidden property here, the result, okay, promise results. And then if that promise was resolved, then I want you to now run whatever I define on the unfulfilled promise array, you know, on the unfulfilled promise array, which is a callback that you're going to pass to the .then. So the .then is just this function that'll run your callback when the promise is fulfilled, okay? But when your promise is rejected for some reason, lack of internet connection, cannot read a corrupt file, that kind of thing, I want you to now run this callback here that I define on the catch here. Or you can also define it in .then and on rejection as well. So the idea here is that we can have now control of how our operation, especially when we need to deal with best scenarios and worst scenarios, we can now have a fallback here. So that's great. And also understand that how this mechanism works, especially in the browser as well as in Node, that unlike callbacks, that it relies on the callback queue as a way to add all of these functions. Once that time is done, and then the event loop will go to evaluate that. If the call stack is empty, it's gonna grab the call, whatever is on the callback queue, okay, the last element on the callback queue, and then put it on the call stack so JavaScript can evaluate it, and then pop off of the call stack and continue the cycle, right? But with the case of promise, now we have something called the micro task queue, that now the event loop is going to evaluate this if the call stack is empty, and by default or by design, the event loop will gonna grab all of these elements on the micro task queue until it's empty. So if you're not careful of how many, or if you are continuously adding tasks to the micro task queue, you may end up with an endless task. So effectively, you are never going to reach to the callback queue. So you have, this is the thing that you have to be careful here on how you wants to work with promise. And now, as a way to understand this new syntax called async and await behind the scenes, we need to look at how iterators works. So this particular way of how can we access to data, okay, this new way of thinking of how can we access to data. And that's quite interesting, because with iterators, it recognizes a task that we as a software developer actually do. And we, quite frankly, even though that we know how that works, most of the time what we want is to get the data. So this is, for example, most of the time as software engineers, we have to deal with huge collection of data, not one single state, which is, or not one single object, which is known as state, okay? This is what we call in our application as state. But most of the time we need to handle is collections of data. We need to handle is a lot of users. We need to handle is, for example, apply several, for example, if 7 of your friends are sending money to their moms or dads or uncles, okay, we need to actually work on each one of this data, okay? And quite frankly, we don't care about how to access the data. We just only want to know how can we work with that data. And that's something important and especially powerful here. because most of the time our job is based on how can we access the data to apply the proper transformation or the proper functionality to this data. And that's exactly what this iterators is going to allow to do, okay? Which are some functions that anytime you run that, okay? Some function that anytime you run that, okay, it will give you the first element. When you run it again, the next element. When you run it again, the next element, the next element, the next element, and the next element. So now that we know how iterators works behind the scenes, by using one of the features of one of the beautiful features of JavaScript, which is closures, okay, as a way to now keep track at which position we are in these collections and then return the proper value. There's some caveat on that, because if you're going to implement your own iterator or your own function that allows you to get data out of this collections, you also need to find a way that when you read the end, clean up the memory. So this is it, okay? And especially here with this particular function that we look at this, it actually is now define a function called inner or next. We can have that ability for this. So let me in fact do something like this.
Here we go. When the function inner is defined, it gets a bond to the surrounding local memory. We've got that bit, which has been defined. We return out the function known as inner. The surrounding live data is returned out to attach to the back.
In the diagram.
Now we move on to iterators. Okay, iterators. Iterators. I said the very
Okay.
start, when we run or we write and run code, what we're typically doing is taking data, storing it, and then functionality that we then apply to that data.
Exactly, but this is like the value proposition of this. So the value proposition here now with promise here, and not only with promise, web API, callbacks, micro task, queue, and the event loop, is that allows us to defer action until work is done or complete, okay? While in the background, we're continuously running our code line by line. And this is what now provides this asynchronous JavaScript, which is the backbone of the modern web. So this asynchronicity in JavaScript is what allows is this modern web applications to work. So for example, so you can see now in real time is your bank balance. or some of your tweets, or some of the TikToks, right? You shouldn't get addicted to that. Again, it is your responsibility. You're a grow-up people, okay? You're a grow-up person, so you better know what to do with your time. In any case, so now here we're talking is about iterators. Let me in fact actually do this. Iterators here. Okay. So the thing here is, with iterators, we are now effectively recognizing something that we as a developer actually do that, and that is, most of the time we need to apply functionality to our data, and we do that is by one object, and this is known as the state. Okay, so hey, you want us to apply this amount of you have now this amount of money, and you want to apply a functionality to that, let's say withdraw or deposit. Okay, so this is known as the state. But as developers, usually we have to deal with collections of data, collections of objects, whether it's in a hash or map. It's the same: set, list, arrays. Okay, and so actually the processing or actually the process of accessing data is a task in itself. Oh yeah. So wouldn't be a better way to actually, we don't need to take care of how we access the data. We just only get the data that we want and then apply the transformation to the data. So wouldn't be better to be a better way to, anytime we run a function, we get the data that we need to, and we run the function again, we get the next data from these collections, and so on and so forth, and that kind of thing, right? So that's why now instead of us have to manually accessing to the data and be descriptive about it, okay, be imperative, indicate now the language how you're going to access to each one of those elements. Now we're going to have these functions that will give us is the element of that collection at that position. When we run that again, we get the next one. We run that again, the next one. But how this process actually works, okay? How is getting all of this data, and how is keeping track of all of where are in the collection? Here is when there is a beautiful concept that we're gonna see that called closure, that allows to these iterators to keep track of these things. So first thing first, we need to look at how can we do that manually. In other words, how can we be imperative as a way to access to this data? Okay, so for example here, something that I'm quite familiar with. For example, you can define is it's going to define is a collection here called is numbers. Okay, so now you have is 5, 6, and 7. Okay, make it like this. All right, and then you want to now iterate access to these elements. Okay, so the imperative way to do that is by defining is a for, and these for are known as for loops in JavaScript. But no, give it to me in English. That's right. This is known as control flow and error handling. Control flow and error handling here. But this is control flow and error handling, exactly. The catch block. As a way to run a synchronous tab, utilizing error object like that. And then you got this. This is quite interesting because variables, control flow, and loopings. Exactly. This is part of the core. Variables, control flows. Okay, so control flows. Variable control flows and loops and iteration. Why this is important? Because especially most of the time, that's what we're gonna do as developers. And now, since the language has evolved, okay, since the language has evolved, traditionally we have this particular way of doing this. Okay, we say, hey, for using is let for this. So we're going now to define is an index, okay, that allow is to iterate until this condition. So we know this, so we know the length of where we're going to iterate that, okay, which in our case is the num until I is less than the number dot length minus 1. You may wonder, why is this? Well, because at the end of the day, length start with it tells you how many elements do we have, and since we need to iterate in access to the data, where we access the data to the 0 position, that's what happened. So the 0 position of this, the thing here is that we initialize this as 0 because we are indicating that this is the first address. Okay, it indicates is a position. It indicates is a position. So 0 is the way how do we start here instead of 1, which is kind of interesting. Remember, we are putting its address. We're not indicating is if this element exists or not. Okay, that's one of the difference between the 0 and 1. So 0 here we are using that as address, as place that we like to go with. Okay, where now if you're starting with 1, it indicates its absence. It indicates its existence. In our case, that's one of the subtle difference here. But in any case, that's one of the reasons why we have this particular rule. And then we're saying what you want to do. Okay, you take a look now here on the for statement. Here they say, hey, this is the initializations, this is our condition, and this is the after through. So what we're going to do after we evaluate that? Well, we're going to now increment that value. So why this is important to recap? First, because here we're going to see is how are this new particular way of how can we, this new way of how can we access to our data. So far so good, no problem at all. So here's our initialization, here's our stop condition, okay, or our condition, and here's the after through. The after through is that what am I going to do after I evaluate this? I evaluate this block here. So as a way to now access to this element, you say, hey, I want you to now access to this element, to the numbers, by indicating now, hey, in a dynamic way, I want you to access to this element in the position of that. All right, and if we run this, we get that as expected, right? Oh, I mean, is this as expected? All right, as expected. Okay, so far so good. The initialization, the condition, and the after through. What you want to do after this. This is pretty much a standard. So as you can see here, you can quickly imagine that if you have, for example, nested collections, okay, it is something that can become now quite cumbersome to get in there, you know. So, but even though, okay, the idea here is that recognize how you can access to the data here. So now with this particular approach of how can we access data in JavaScript or in any other language, okay, is that wouldn't be better if we define a function, okay, let's say the iterate, okay, let's say the iterate, right, that we're going to get is an array, and inside of this we're gonna define as well or initialization here with or initialization here with this I equals 0, okay, and then we're going to define now a function that is gonna run, and anytime this function runs, we're gonna get this element. And one of the great things of this is that now we have much more control about how elements can we access to this. So for example, we can say, hey, this is a function called inner, all right, and now this function inner, all right, it'll say, hey, I want you to now return is, well, the array at that position. This is what I'm gonna do. So there is something interesting here that's going on, especially if you return this inner as a reference, and that is it's going to create now a closure, which means that this function can have access to the outer lexical scope when you run this. So initially here, this is what is going to be passed down to the inner function. Okay, so all the outer lexical scope we're going to pass down to the inner function here. So initially it'll be 0 anytime you create this new function, which means that, hey, so to find this function here like numbers, you call iterate, come on, iterate, and then you pass is this collection 3. Oh, okay. Well, numbers, iterate, iterable, you know, numbers iterable. So these numbers iterables here, so anytime, because now what it's doing here is important to evaluate here is that, hey, we are going to now return whatever iterate function is given to us, and that is, well, first things first, I'm going to, so when you do this, JavaScript say, let me create a new branch execution context, that here the array is the things that are going to set in my function variable execution, my function variable environment here, where the value will be 1, 2, 3, as well as the E, right, as 0, and that's it, right? So this is now what these functions hold in this backpack or in this closure here. So now anytime we call these numbers iterables, okay, which is a reference to the inner function, which is now calling is this, exactly, because now we are passing this function here Let me here refresh here. Exactly. And here what I want is to pass is now this particular object called inner. Okay. So that's pretty much what I want to do here. So once I define this function here, okay, and when I call this, for example, with numbers, okay, is iterate, and then I'm going to pass is the value here, 1, 2, 3 here. So this first line of code is say, hey, let me define the label numbers in the memory and assign that whatever iterate functions return. And for that, I need to create a new execution context here where you say, hey, the arguments here, or the parameter array, which argument is 1, 2, 3, this is what you're going to hold on local memory, as well as the I0 as 1 here, and that's it. And then you return this function, this object function. So okay, so far so good. So the idea with iterations or iterable is that when now I call this function called inner, I get now the first element, and then I can get now the second times the next element. Oh, what happened here is that what happened here is that okay, so once you return this, because that's what we need to do, this is the const value, okay, and then increment that, and then return the value here. Why this is important? Well, because first we're declaring is this function that you're going to receive is this array, and the we're defining is the E as 0, and once we run here, we want us to now assign this value, increment that, and return it. So this is something that I'm quite familiar with. So for example, if you define now your numbers and iterate as a way to now iterate through each one of those elements, and then you say, hey, numbers dot inner, okay, I want you to give me is the first element, and the second time what you give me is the second element, and the third time is the third element, and of course the next time around it would throw an undefined because it doesn't exist. That's what you need to define is this inner logic. But again, this is pretty much what we want to achieve, which is something that we did here. Pretty much that we want to achieve. So the thing here is that with iterables, we are returning is an object for that, and anytime we want to run that, we can get now the value of this. So before moving into that,
here we go. On the function
okay, so before moving into that,
cool. These are going to get so much more powerful in a moment. But first,
we are going to now actually run this particular iterator here. Yep. So type JavaScript here and click run the code and press Ctrl+S. First things first is this. Sum an array, your code here. Your challenge is create a for loops that iterate through an array and returns the sum of elements of the array. B, create a function iterator for an array that returns each value for the array when called, one element at a time. Some function, exactly. Or A, this is what you can do here. Create a for loops that iterate through the array and return the sum of elements of the array. One way to do this, okay, is by saying, hey, instead of defining as a for loops, to do that, we can do that. In fact, let me do this here. We can say, this is the imperative way of how you can define all of this for loops and conditions. But here we're going to put a practice. Here is the for loops and iteration here. Okay. Loops and iterations. Label statement, the break statement, break into a label, continue statement, it terminates the current iteration of the innermost and closing while. Increment expression. A loop iterating over iterable objects. This is for in objects and for off iterable object. for all of this iterable. Interesting. Iterables object. Iteration protocol aren't new built-in or syntax, but protocols. Okay, ways to do this. This protocol can be implemented by any object by following some conventions. There are two protocols, the iterable protocol and the iterator protocol. The iterable protocol allows JavaScript objects to define or customize their iteration behavior. Such as values are looped over in for of construct. So built-in types are built-in iterables. Built-in iterables. There is no object in core JavaScript language that is an async iterable. Some web APIs such as readable stream have symbol.async iterator method set by default. In generators returns a generator object, which is an iterable iterator. Okay. Let's chill. Because after all, here let's going to define is these iterators. Okay. Okay. So initially we're going to iterate that on this is the initializator or initialization, the condition I is less than the array.length. Okay. And the after through. So the after through is this. What you're gonna do after through. Okay. This is it. And what you're gonna do is just to return or do something like this. Define is a value outside here, a block scope value variable called result. You can say sum, that'll be initially 0, and then you're going to do is now sum, you're going to increment and then assign that. Okay, you're going to add and then you're going to assign and then add that. That's why we have is this operators. The operators here the operators or the assignment operators the assignment operator. So this is built-in object, expressions and operators. That's right. Expressions and operators like this. Okay. When you say, hey, the addition assignment here, operators perform addition, which is either numeric addition or string concatenation. And that's what you have to be careful. You need to say, hey, is any string that I'm getting here is a string, is a number, good. This is addition assignment here by saying this, okay? On the two operand assign the result to the left operand. So what it's doing here is that perform addition, and if you are a number, it's gonna add that. If you are a string, it concatenate that. That's what you have to define here is which type of data that you're going to receive, okay? Because you can say parse int, and then say, hey, this value that I'm getting here, I want you to transform this into a number. I want you to transform that into a number here. So the addition assignment. Exactly. So you're going to take the current value, and assign this new value. You're going to take the current value and the new value, add addition, and then assign that to the left side. So after that, I want you to now return is the sum. So if you uncomment this line here, that's exactly what we should return, right? It's 10. It's a type error on line 100. Return sentence is undefined. What? Oh, okay. No problem. All right. So this is one way of how you can define this. Okay, this is the imperative one. Okay, this is the imperative one. Honestly, I don't want to define this. The imperative. Okay, it's the imperative. Okay, now the other is now the declarative. Declarative, where you say, hey, since this is an array, okay, now I want you to apply this transformation or this functionality here to each one of those elements, and initially you're gonna get the accumulator followed by the current value, okay, and for each one of those elements I want you to do is this. I want you to now to this current and initial value, I want you to add that with the current value, okay, and then that's it. So we're gonna start is with 0, and because this reduce function is returning is a single output, not a collection, we can do is this, and array that reduce the accumulator. Oh, of course, this one you got it. That's one of the powerful things of the reduce, and I know that it can be obfuscated. It can be quite confusing with new people, but at the end of the day, we are using this as a way to save us time, as a way to anytime we need to apply, we need to go through this collections. I want you to now generate a single output. I want you to now is create, for example, it's an object or applying a mathematical operation, in this case, like this. That's something interesting. That's very, very, very interesting. Let's say you want us to now do something like this, okay, where the value is where the value is 0 and the current value, okay, and the current value will be a collection of this. So once you do this, you can say, hey, I want you to now return is this new object. So evaluate this expression that the value here will be this one, okay, and the current value will be is you get now on Okay. Since our accumulator is this object, the first thing I want you to now have is this, the current value, exactly, plus the accumulator value, like this, because what we're saying is that, hey, what is the previous accumulator value? Well, is this. Is the current value initially, where it's 0, and then the previous value, and the actual value, which is 1. And then you want to have here is this, accumulator dot current value followed by the current value. So now if we return this, we get exactly as expected, 10 and all of the element that we receive. This is one of the powerful things of this particular this is one of the powerful things of this particular function, is that given this, okay, given this, what we're saying is that we're going to spread all of the properties from these objects, and let's going to update the values here as expected. So now we have now an object, okay, in which value is that, and also all of the element that we get from that. So here we are now applying a transformation to each one of those collections, okay, and updating their value as we pass through that. That's something beautiful. That's something powerful. That is, it is. And then you get the value. That's one of the powerful things of this reduce function, okay? And I really love about this. I really love about these powerful things that this, I think reduce MDM here. This reduce function, okay, allows to do. So it allows us to apply a functionality to each one of these collections of value, and I think that's lovely. I think that's beautiful. And I think that's beautiful. And I think that's beautiful completely. The reduce function method is an iterative method. You know, it's an iterative method where you say, hey, this is the callback, this is the functionality that I want to apply to each one of those elements on the array. Iterative method. Many array method takes a callback function as an argument. Exactly. Many array method takes a callback as an argument. The callback function is called sequentially and at most once for each element in the array. The iterative methods. And the return value of the callback function is used to determine the returning value of the method. They all share the same signature. All iterative methods are copying and genetics, although they behave differently with empty slots. The following methods are iterative: every, filter, find index, find last index, flat maps, for each, map, and sum. In particular, every, find index, find last, and find last index, and sum do not always invoke callback function on every element. They stop iteration as soon as the return value is determined. Exactly. The reduce and reduce writes methods also takes a callback function and run at most once for each element in the array, but they have slightly different signatures for typical iterative method. For example, they don't accept this argument. And then the sort method also takes a callback, but it is not an iterative method. It mutates the array in place. That's what happened. That's why we have the to sorted as a way to not mutate the current object here. Generic array for that. So why this is important? Because now that we have this particularly iterative functions, okay, that allows to actually do something that this is a typical solution for a common problem. Okay, this is a typical solution for a common problem. Mutating methods with all of this, non-mutated alternative, slide a 0 minus 1, concat, to reverse, to sorted, to splice this. Preserve empty slots when doing the copying, so in the end the array is still sparse. So this is something interesting here, because now that we're going to look at how can we actually access to this particular functionality here, again, as a way to solve these small problems, and then you can scale that up, right? Then you can scale that up. But the whole point of this is to look at how we can have access to the data. We don't have to be explicitly tell how to access to the data, okay, which is a task in it itself. And also we can apply a functionality to this data. The result of that will be applied to the next one, and so on and so forth. And then you get it. This is the reduce function. So far this actually worked as expected. Okay, again, one of the imperative and the other is the declarative. I want to now make it this much more cleaner to say, hey, accumulative, it will be add these two elements first and then assign to the left side by saying current value, okay, and then the initial value will be 0. So you get this. So far so good, no problem at all. And then increment the line below to test this. Okay, then you say return iterator array. Okay, so now is when we're going to create these functions that allow to have access to each one of these elements in our array, the iterators. So anytime we run a function, we get the first element. We hit that again, we get the next element, and so on and so forth, blah blah blah. So here we're going to define is our index as 0, and then a function here. What do you call here? Okay, well, it's going to return now a function here. We can say is, let me define is this function called next. Okay, in here we're going now to say, hey, get the value of this. What is the challenge 2 here? Create an iterator with a next method that returns each value of the array when next is called. So like this. So now we can exactly say create an iterator with a next method that returns each value of the array. So we want to return is each value of the array. Increment that position, and then we're going to return is the value as it is. And here we're going to return is now the next function. Okay, as it is. So now that we uncomment this as so, lovely, no problem. Okay, so anytime we now call this, we're gonna get that A, then B, then C, as you can see. Then we got is the next iterator. Write code to iterate through an entire array using next iterator and sum the values. Because we already defined is that particular functions here, okay, it's called return iterator or next iterator. Okay, write code to iterate through an entire array using next iterator and sum the values. So in this case we can say is, since the output of this is sums the value, we can say, hey, first we need to define is our index here as a way to keep track of where we are currently in these collections. Second is the result, okay, which is the sum, because this is what we want to return. And then we now define is this function called next, all right, where what it's gonna do is to get the value. You can say current value. You define this as a const, okay, which will be is the array at that position. We're going to increment is the index as a way to say, hey, go to the next one the next time, okay. And now return is the sum that you add from the current value and then assign that to the sum, right? This is it. If we want to improve readability, we can say result here. That'll be this. and then do this, but it preferably use this and then return result. Alright, pretty much that is it. And we're now going to return this by saying we're going to return now this as an object with the next function as a reference, because when we're going to call, we want it to actually at runtime we want it to call this. Here we're passing is the reference, and that's pretty much what we're doing here. Exactly. So when we run this here, the first time we're going to now sum that. Write code to iterate through an entire array using X iterator and sum the values. Exactly, and sum the values. Iterator with next. Okay, and sum their values. Okay, return is the current value. Like this. Challenge 4. Create an iterator with a next method, and anytime you call an iterator is a closure. Okay? Create an iterator is create a closure that allows to access to the data here in this particular order. Okay, create an iterator with the next methods that return each value of a set when next is called. No, wait, what? Is this one? Exactly. What? Okay, anyway. Use your next iteration function. God damn it. Exactly. So here what we're gonna do is, well, let's going to use this our next function here. This is the next iterator. Okay, so we're going to invoke this here, and when we get that, all right, once we get that, so which means that let's go into define is now is this. Okay, let's go to define now this next iterator here. Okay, where we're going to define here some sum as 0, and then our next iteration function, which is this one. Let's say, hey, this is the iterator or iterator with next, right? Here we're going to the pass down is no. In fact, what we can do is once this is done, we can do is do or while the array dot length is less than I, or why this index is less than I. Okay, we want to evaluate this, which is we want us to now call this function. the next iterator. So we're going to call the next iterator. But for that, we would like to say something like this. This is next iterator, or iterator, exactly, is iterator with next, which is our function here that's going to accept that array. Okay, we're gonna pass that, and what we're gonna do is to say is the, okay, we're gonna call this function, I don't know for how long, but we're gonna call this, but we need some stop condition. So the stop condition could be something like this. So if the iterator with next is undefined, okay, while this contains something, I want you to now do this. Iterator dot next, because it's this, well, this contains something, okay, I don't know how many of them will be this collection, but as long as they contain something, all right. This is the iterator here. That'll be this. We're gonna call that next iterator, like so, exactly. And we're gonna do here, I want you to now sum the next, these elements with the current sum, and then assign that to this. And after that, I want you to return is the sum. What are we doing here? Glad you asked. So first we're going to define is the sum, okay, as 0. So when we run this function, the first time, we're going to pass is the array, okay, and then with iterator with next, we're creating that instance, we're creating is our iterator, okay, to set that, the logic of how we're going to access to the data, okay, and we're going to iterate through that until we don't have that more elements here. Which means that if the next element, exists, okay, if we got an element, okay, now sum this. Well, we get an element, do this. The problem with this is that if we call this, okay, the problem with this is that if we call this, this will behave as you call me. So this is the first element. You know, you call me, this is the first element. So the next time you call here, it say, well, you already called me. So this is the next value. So we don't want to do that. In fact, we want us to do something here. Value here, this one we can say current value. So as long as we have value, which is the current value, I want you to evaluate this current value, which is this. As long as you have a current value, okay, so while current value exists here, okay, I want you now to do this. This is quite interesting because let's walk through this code. It say, I want you to know while here the current value. The question is that, do you have current value there? Do you know what current value is? Because you define the current value is inside of my scope, man. Exactly. It's like I don't have current value here. You know what I mean? How can you do this? Okay, is empty. We can do this like so. You define here, your logic here is empty. There will be a boolean. Initially we have something. We can say is empty false. I want you to evaluate this only if is empty. Well, empty is false. I want you to evaluate this, right? If the current value, okay, if the current value exists, okay, do this. Otherwise, is empty is equal to false. Is equal to true, sorry. Exactly. This is this particular logic that we define here. Okay, and in fact, where actually is, well, returning the sum of that, which is 10. This particular logic here is indicating how can we access to how can we run logic here for each one of those elements. Especially if you don't know the length of that. Especially if you don't know the length of that. Okay, this may be another way to put it. Hey, do we have the next element? Okay, do we have now the next element? So is next element X. So as long as, hey, well, next element exists, this is what you want to do. This is what you want to do. So, well, next element exists, okay? This is what you want to do, which is sum. Sum is, so sum, take the sum label, take the sum variable, and the next, okay, to add them, and then now let's go to call the iterator with next dot next. And make the new, and makes the next element update that. Exactly. And then your return is that. That's quite an elegant solution here. Exactly. This is how you can now say, all right, with the function is an iterator that we're going to iterate to a collection of values that I don't know what it is, but as long as you have a next element, great. And this is something powerful here because you can work with collections of elements that you don't know the length of that. So for example, linked lists, double linked lists, trees, array, trees, in graph. That's pretty interesting. That's pretty interesting, man. Oh, it's because it seems like the word iterator is a reserved keyword. Oh, of course, it's because it's iterator. So we hold the reference of this function, and then we're gonna call the next, and that's supposed to work. That's interesting. That's quite interesting. That's quite interesting. There might be some reserved word, reserved keyword here. Oh, of course. Is iterator function. I am never updating is the reference here for that, and now the code will work as it is. All right. That was the challenge 3. Is that define a code iterate through an entire array using the next iterator. Using is, hey, I want you anytime. So if you don't have the next, so if the next element, so if this element exists, I want you to run this function again. If this element exists, I want you to run this function to get me the next element. Get me the next element. So you don't know how long is this, but as long as you've reached the end, period. And then you return this. That's something interesting here because now it gives us is this new particular pattern of how we can access to the data. Okay, instead of manually describe that with the for loop, what you need to have is the fixed length, a way to iterate through all of this or access into all of these elements. So now here you can say, hey, I don't know how many elements do you have. Recognize this dynamic nature. But I want you to access through that in a way that is easy for us to manage and that you can keep track everything behind the scenes. So by the time it's done, you can go and access. So when you reach the end, that'll be all. That's quite interesting and powerful, bro. It's quite interesting and powerful. All right. Okay. Okay. Next is challenge 4 here. Creates an iterator with a next method that returns each value of a set when next is called. with a set. Okay, pretty much the same, because after all, this is an iterable. All right, so if we take a look now at the set here, our collection of values. Okay, in which their value may occur only once. So here we're gonna do is this. We want is to get what? Return each value of a set when next is called. Okay, we define here as our index as a way to know where we are in this position. Okay, yep, where we are in this position. So if you take a look now at the ECMA specification here of set, here you say set here, abstract operations, operation on object like set here, but I want now to take a look at the abstract construct set text argument object p property and here, and throw a boolean and return either normal completion containers or throw in a section. Set records is this one, key collection. Okay, because this is an operation of the operation on object. Okay, as a way to set this, no, the set record here, key collections. Okay, this is an object, set object. Okay, the size, has, and keys. Good. So this is the shape of this. So you have now these abstract operations: get set record, set has data, set data index, and data size. And data index, and set the constructor. So this is an iterable here. Okay. So property with the set constructor, set prototype of, properties of the set instance, property of the set instance like this, are an ordinary object that inherit property from the set prototype. Set instance also have set data internal slot. So this is, after all, is an object. Set iterator object, create iterator. Property of the set instance. After all, this is an object that you can iterate through that. Set an ordinary object. Is an ordinary object. Okay. So because these collections, it'll be treated and has an internal slot called set data. Set prototype add and clear and delete difference entries and for each. Okay, so here the idea here is, since we're going to receive this set, okay, since we're going to receive here is this set here, exactly, therefore it could be represented internally as a hash table, a search tree, or any other data structure, as long as the complexity is better than ON. Question: how is this? Is the type of this? How is the shape of this set? Say new set 1, 2, 3, 4, 5. Okay. Okay. It's like an array. It's like an object here, but it behaves like this. But it behaves like this. All right. Again, this is how can we access now to this particular data set, data structure, as a set, which holds only unique values. Okay, which hold only unique values. So here we got, is it write code that iterate through an entire array using the next iteration? No, it's for create an iterator with the next method that return each value of a set when next is called. That return each value of a set when next is called. Okay, this is quite interesting. And it transformed that into unique values. Oh, it transformed that into unique values. That's blazing powerful. Okay, it transformed this into unique values. See, the whole point of this is that iterate through each one of those elements. Okay? But now this data structure. So for example, if you define this, new set, it's a, this is not the way how I get access to this. You are used to the arrays, but now we are going to work is with this particular property, which is get. Oh no. because it contains all the values. Because the way how you can now define that, okay, the way how you can define that, because after all we're gonna pass is a set, it's quite different here. And that involved is how you can get access to this instance methods and instance properties and instance method for that. Return a new iterator object that contains an array of values for each element in the set in the insertion order. This is similar to map, so each entry key is the same as its value of a set. Relations to arrays is to remove duplicate element from an array. 12, 13, exactly. I have one particular approach, and that is to convert that into an array and then work with that. Set values. Set values. New set instance, return a new set iterator. Oh, shit. You return a new set of iterators. Oh, you return a new set of, this is the shape of this. It returns a new, oh my god. It's the iterator. Iterator, next step. Oh my freaking god. Iterator record. Oh my, operations on iterator objects, abstract objects, operation on iterator objects, iterator records. So you got is the iterator that has the next methods as well as the done. Iterator record. This is the iteration operations on iterator objects. Iterator records. iteration record. An iterator record is a record the completion record specification type. Iterator, next methods, and done. Okay, iterator records. Get iterator method from operations on iterator objects. Iterator record. An iterator record is a record value used to encapsulate an iterator or async iterator along with the next method. Is a way to encapsulate that. In other words, is that if you create a new set here, okay, with this particular value 1, 2, 3, and 4, and then you say you assign that to a cons here, and because the new set has a values, so values here is an iterator, set iterator that contains the value for each element in the set in the insertion order. So because everything in JavaScript is an object, these values contain some properties. In this case, it contains the property next here. As a way to give me is the first value of this, the second. Okay, so now, oh my god, so this particular method has an instance of the set iterator. In other words, is that it exposes exactly. An iterator object is an object that conforms the iterator protocol by providing a next method that returns an iterator result object. That returns an iterator result object. All built-in iterator inherit from the iterator class. The iterator class provides an iterator method that returns an iterator object itself, making the iterator also iterable. It also provides some helper method for working with iterators. So in other words here, an array iterator return this. It's because all of these functions return providing is an next methods. All of these functions providing is this next method as a way to access the data as you want, or in this case, as a way to access the data without worry how you gonna get that, without worry how to do that. Jesus F Christ. The following are built-in JavaScript iterators, which means that functions that allow you to now have access to functions that allow you to get the data at a particular position in these collections. You don't care about how is getting the data. You just care about that work with the data. Holy moly. Exactly, because it returns an iterator. It's because it returns an iterator. So from the arrays, values, keys, entry, array iterators, type arrays, in the stream, it exposes the iterator as well. The map iterator returned by prototype values, okay, from values, keys, entries, from the set data structure, values, keys, and entries, from the regular expression as well, and stream prototype dot match all. It returns a new, okay, return by is an iterator. The generator object returns a generator functions. The segment iterator returned by the iterator method of the segment object returned by internationalization project. This is internationalization. Segmentor prototype segment. It returns instance segment a string according to the local and granularity of the internationalization segmenter. And the iterator prototype map. Each of these iterators has distinct prototype object. Oh my god. Each one of these iterators has a distinct prototype object which defines the next method used by this particular iterator. For example, all string iterator objects inherit from the hidden object string iterator prototype, which has a next method that iterates this string by code points. String iterator prototype also has two string tag property whose initial value of the string. All of these prototype objects inherit from the iterator prototype. Iterators helpers. These methods are iterator helpers, not iterable helpers. Iterator and iterable is different, because the only requirement for an object to be iterable is just the presence of the iterator object. Okay. There are no shared properties to install this method on. The iterator class itself provides some helper methods for working with iterators. For example, you may be tempted to do the following. The first, convert the iterator returned by the map prototype values. This first converts the iterator returned by the map prototype values to an array. Then use the array prototype reduce The first converts the iterator, this iterator returning by map prototype values to an array. into an array, because this is converting is the value, which is an iterator that exposes the next function, okay, into an array. Then use the array.prototype reduce methods to calculate the sum. However, this both create an intermediate array and iterates the array twice. Instead, you can use the reduce method on the iterator itself. In other words, directly on the values. Because this is an iterator, it means that this is a function, okay, that anytime you perform these functions that recognize that this is an iterable, because it only iterates the iterator once without memorizing any intermediate values. Iterators helpers methods are necessary to work with infinite iterators. Iterators, because it only iterates through iterator once without memorizing anything intermediate values. Iterators helpers method are necessary. Exactly, when you to run this, iterators functions are helpers when you want to iterate or when you want to work with infinite iterators. When you want to do infinite computation, you don't know how long it will be, but you want us to get that one at a time. You cannot convert sequence to an array. As far as necessary to find the first value that satisfies the condition. Wow, what the fuck? So this return is an iterator. Okay, this return is an iterator with the values, and anytime you want is to, okay, this return is an iterator. Oh my god. So this return is an okay. This return is an iterator. Jesus fucking Christ. This is the iterator, right? Iterator from our new set. You pass these values here, unique values, by doing this thing here, which means that you get this reference of this function, okay? And anytime you call the iterator here, followed by the next function here, you're gonna get that. Holy shit. So because you now so values, what it's doing is that, hey, I'm going to wrap this into a function called iterator that it will expose is the next method, so you can have access to this value here. Great for doing infinite tasks, all right, or tasks that you don't know how long the length of this. So for example, when you want to iterate through linked lists or that kind of thing. Jesus freaking Christ. Sem época. I'm a redhead. All right. So this, this, it makes a lot of sense. So because after all, okay, because set is here, because set is a particular data structure here. We can take a look at this. Built-in objects like set here, where it is set, okay, where now this store only unique values, okay, and this is actually pretty much, you can think of this set and map like a hash table, okay, where with set it allows you to only have unique values, whereas with map you can only have is unique keys, okay, and with that you can work with solve complex problems. All right. One if you want unique values, the other if you want to unique keys, okay. What curriculum? What the fuck is this? This essential skill set for new front-end developers. What? This is new. What? Constant learning mindset. Oh, MDN CSS trick dev. Frico Cam. A Lisa bar. That Lisa bar is something that I have eons. User research is storytelling. To ignite personalization practice, run this pre-personalization workshop. Got a lot of time to do this article. Wow. Anyway, that go beyond the scope of this, which is something great. It's part of the MDM curriculum. Web standards. And it is funny because there is a lot of people that they don't know what is this. You know, there is a lot of people that they don't know what is even the fundamental of that. Client and service and the role, DNS and how it works at a high level, TCP, IP, and HTTP, HTTP syntax at basic level, common HTTP response code, component URL, protocol domain and subdomain, TLDRs, top level domains and how to register a domain, and hosting, how to purchase and how to put out website online. Web standards and web platform design principles. Okay, again, this go beyond the scope of this, but this is something, well, all right. Okay, this is new. Okay, completely this is new. How the web works. Publish your website. Using a web-based ID such as CodePen. Publishing via GitHub, which is way much better and faster. A DOM tree is assembler for the download HTML. Semantic web. Background and borders. CSS styling. CSS layouts. Float positioning. Model layout like Flexbox and CSS Grid. I love CSS Grid. I freaking love CSS Grid. Responsive design. JavaScript fundamentals. Conditional functions, JavaScript object basic, DOM scripting, and event. Network request with fetch. Debugging JavaScript. Accessibility. Accessible styling. That's quite interesting here. Design for developers. Basic design theory, UI fundamental, construct, typography, visual hierarchy, scale, alignment, use of space, of what space, color theory, and use of image. User design, user-centered design. The shape of it, okay. That's quite interesting. Shape of design book. Design trampoline, practical typography, web typography made simple, web style guide, virtual design rules can safely follow every time. 16 little UI design rules that make a big impact. And then the version control. That's quite interesting.
Hello, my name is Gary Simon, and I've been a
What the?
UI designer and front-end developer for the last 20 years. And some of you may also know me by my YouTube channel Design Course, which I've ran for the last 10 years. Now, this course is geared towards front-end developers who have at least a basic understanding of HTML and CSS, and that's because we're going to use CSS to realize effective and great-looking UI designs in the browser. Now, the only way to produce good UI designs is by first understanding the UI design fundamentals, and that's exactly what we're going to focus on in this course. You're going to apply these fundamentals through a variety of interactive examples here on Scrimba. Now, this course is actually just a small sample from my upcoming UI design bootcamp releasing here on Scrimba. The full course will contain hours upon hours of UI design loaded with challenges and interactive examples, all to help you develop the necessary muscle memory to either improve existing designs or create
The muscle
UI designs from
memory.
scratch. So refresh this mini browser and click here to leave your email, and you'll get sneak peeks of my upcoming bootcamp, plus it will guarantee the very best price when the course launches. So let's get started. Welcome to this lesson where we're going to talk about the first UI design fundamental, which is white space. Now, before we begin, I wanted to note that there isn't one UI design fundamental that's more important than the other. I'm just arbitrarily choosing to start to talk about white space here. So white space, sometimes referred to as negative space, is the empty space between the elements in your user interface. It's very simple. It's just basically a void of space, but that's really what gives your layout structure. So coming over here, we have two examples. We have two cards, and right now they're designed exactly the same. And there's something wrong with them, and that is, you guessed it, white space or negative space. Now, we can see white space all over the place in the absent areas of these cards. This would be referred to as white space. And in fact, if we're just looking at this layout with two cards here in the mini browser, there is good amount of white space between these elements, but what about inside? So we see this very little white space between the text elements and this container, and also between the title and the paragraph. So actually there's three areas where we're going to improve the white space, and you're going to see just how much better this ends up looking. Adding M units, 0 EM would be objectively horrible. I would margin volume the lines of the text. I need to increase this maybe by about 1.5. So now, overall,
Hi there, this is Peer from Scrimbot. I just want to take a quick developers. So here you have a clear path ahead of you that has proven to work again and again for students in the Scrimbot community who went on to get jobs after completing this career path. And when going through the career path, you can choose between two different ways. You can do it as a pro member, that is the affordable option Scrimbot learning experience, just as you would at a regular school or university. And teachers, we have a bunch of vetted practices you've adopted and make sure that you are actually a teacher so that you get a place to ask questions, this image to get to the Scrimbot immersive landing page, and this image to get to the front-end developer career path page where you can check out the
Screamback. That's quite interesting here. Okay, again, this go beyond the scope of this, because after all what we care about is actually focusing us on the iterator here and see how now can we, using a set, which is this building objects that has now the set of MDN docs here, okay, that this now, come on, in English, please. Okay, that this now have is something very interesting. Performance set comparison, set like objects. All set composition measures require this to be an actual set instance, but the argument just need to be set like. A set like object is an object that provides the following: size, has, and keys. But again, they're all exactly, and the key is meant to return an iterator. Oh my god, oh my god. So as you can see here, right now, this is the shape of this set like object. It has size, it has these methods: size, has, and keys. But keys is an iterator. It's these functions that allow us is to the iterator protocol. Exactly, it's this way of how we're going to do this. The iterator protocol defines a standard way to produce a sequence of values, either finite or infinity, and potentially and return value when all variable has been generated. So in other words, it's the way of how you can produce a sequence of values. And the iterable allows JavaScript objects to define or customize their interaction behavior, such as what you are loop over in a for-of construct. So, but again, the iterable protocol allows you to customize the behavior of this, the behavior building iterables with a default iteration by behavior such as array or map, while other types such as objects are not. In order to be iterable, an object must be implement the iterator methods, meaning that the object, one of the objects up to the prototype change, must have a property with an iterator key. Okay, with an iterator key, which is available via count symbol.iterator, a zero argument that returns an object conforming to the iterator protocol. Symbol.iterator. Whenever an object needs to be iterated, such as the beginning of a for of loop, iterator method is called with no arguments, and then return iterator is used to obtain the values to be iterated. Now that when this zero argument function is called, is invoked as a method on the iterable objects. Therefore, inside of the functions, this keyword can be used to access the property of the iterable object. The function can be an ordinary function, or it can be a generator function. But again, this is what indicates the behavior of this object. How this object is going to behave, or customize the iteration behavior. Iterable protocol, an iterator protocol, which indicates is that how you're going to produce a sequence of values with the next done in values. Oh my God. The next method can receive a value which will be made available to the body, but no built-in language feature will pass any value. The value passes to the next method of generator will become the value of the corresponding yield expression. Optionally, the iterator can also implement the return value and throw a section. Return value and throw a section, but they are optional. A function that accepts 0 or 1 argument and returns an object conforming to the iterator result, typically with value equal to the value passing down equal to the true. Calling this method tells the iterator that the caller does not intend to make any more next, and calls performs and cleanup actions for that. Throw. But this is the shape of this iterator. So you have the iterable protocol that actually modify is the behavior of how you're going to access to this element, or how you're going to iterate through these elements, and the iterator protocol, which is a standard way of how you can produce a sequence of value, or how you can access to this one. And because now set, because when you create is a set, for example, new set, which is a data object, which is a data structure, or a new object set with this value, it will evaluate that if you for some reason has repeated value. If it is, it only takes unique ones. Okay, that's great. That's great. That's powerful. It only takes unique ones. So, because now this object has properties like size, has, and keys. Size contain is the number. Okay, so contain is how many of this do you have. So you say new set size, like this, which is great. Has, which usually perform is any access operations and returns a boolean in a linear time, in less than a linear time, which is much more faster than an array. Okay, so far so good. And it will return is that, hey, do you have this? Do you have this 7 value? You know, do you have this particular value? You do, it returns true. And the other is keys for that, where now keys here is an iterator. It means that it returns an iterator of the element of that. A return is how you're going to access to this. becomes new set here, which is it's going to build this object here, set, where here we're going to pass all of these values. And here's, because it returns a new iterator, that the shape of this or this iterator protocol allows us to get access to all of this data as we need it. Okay. Anytime we run this function specifically, oh my god. Okay. And the way to do that here, and the way to do that here, the iterator protocol expose is the next function here. So it expose is this object that will contain is the next element, as a way to, anytime you run this, okay, anytime you, for example, define now an iterator here, iterator here, and any, so now that you have this object that has a wrapper around this collection of values, that here anytime you call the next, you're gonna get the value of that, which is the iterator dot next, which is a function that did expose dot value. Okay, you're gonna get this value, and the next one, and the next one, and the next one. So anytime you run this until you got this undefined. That's pretty fucked up. And that's pretty interesting, because once we are defining this set iterator, that after all, this is this data structure, this object expose several properties like hash, like size, method set, like size, exactly like that, size, hash, and keys. If you take a look now at the next method and the DOM here. Because here we want to take a look at the set record here that contains size, hash, and keys. Okay, that this function is now a iterator, okay, from the key collections. I want to know property of the set instance is an ordinary object, okay. This is now Azure operation for set, okay. Set record, size, hash, and keys. Property of the set construction, property of the set prototype object, set iterator objects. In the abstract operation for set objects like this. So here, now Mozilla says that this is an iterator. Okay, and this iterator, when we take a look now at the iterator record here, from the abstract operations, the iterator record is now an object, or is now a record value used to encapsulate an iterator or async iterator along with the next method. Okay, so what it's doing is creating is this wrapper around this iterable, okay, that you anytime you run these functions, you're gonna get this, you're gonna access to the element. It's going to produce, you're gonna return, you're gonna give you is this value for that. That's something quite powerful and interesting. Get iterator from methods. Jesus, oh my God. All right, okay. So now this data structure or these methods, okay, or this particular protocol called iterable. So the iterable protocol and the iterator, so the iterable, it give you the or it customize the behavior, okay. The iterable protocol allow you to customize the behavior of, the iteration behavior. Okay, it let you define how you're going to iterate through these elements, or how you're going to how you're going to define this iterator or customize the iterable behavior, such as what values are looped over in a for loops construct. And then you got several of these iterables, okay, by default, such as array or map, while other types such as objects are not. So in order to be iterable, an object must implement the iterator methods. So okay, so now that we look at that, especially when we take a look at this code, and that now that we know that this particularly set property, particularly set building object that has this property called size, determining is the length of that collection, the has the boolean that it look out for the data, and in less than linear time, okay, is more efficient than the include methods from the array, and also have this thing called keys, which is an iterator, which is an iterator, which means that the iterator protocol is a standard way to produce sequence of values by wrapping is an object, or by how you can get access to all of these elements, okay, by having this particular interface which exposes the next function, which expose the next function to this. Jesus. Which exposes the next function for this. Holy moly. So here we're gonna call this the iterator, which is this function that expose us is the way of how that function is producing all of these functions once it iterates through this collection, in our case set dot keys, okay, and we're pretty much going to actually something like this. What's going to define is the next element, okay, on the iterator value by saying this. Current value by saying is this iterator that's gonna call now the next here, okay, let's gonna call now the next here dot value, because it exposed the current value at this moment like this, okay, and what we're gonna do is to now iterate through that using a while. This is something great, because if you don't know for how long you need to iterate, so do infinite collections, that's something where you would like to go with. So if the current value exists. All right, let's gonna do this. Let's go now to okay. But we would like to know, we would like to do this. Exactly. We would like to do this is anytime we run this. So in other words, we are doing is this. We can call this as a function here called current value. Okay. We're now inside of this function. We will now is to return is that value, you know, and return the current value here, or in our case we can call this as next as an object here. So once we are passing this, we're going to call that for it as it is. (101) return the iterator dot next dot value. Oh my god, iterator iterator, okay. And then you got it. Hey, holy fuck. Holy fuck here. Like this. Holy moly here. Holy moly again, because set has that particular property, which is an iterator that is a wrapper around how it's going to return values in an iterable collections. Okay, so anytime you run these functions, you're gonna get is, so you're gonna do all of this internal tracking mechanism behind the scenes for you using is closure. Holy fuck. God damn. And then the challenge 5. Create an iterator with a next method that return an array with 2 elements. An array with 2 elements, where the first element is the index and the second value, and the second is the value at that index when next is called. This is with an array, right? Okay, this is with an array. Is the array have a particular property here? Is the array.keys or array.value have this? Awesome. The question is that it is for the values. But we need to do this for every entry. Can we do this? For entries. Exactly. So for every entry, I want you to return me this. Exactly. So now this array function here is now giving me this particular function as we need to. That's to me, okay. So function next here, it say return now the array that has a property called entries, which is an iterator, okay, which is an iterable. Here is an iterator, which is an iterator. This is an iterator, okay. So what we want to now do is, which is a naive approach, is to say let's going to iterate through this that contains the values that contains this wrapper function that exposes the next method. Hey, when I run this function, give me this element. And the way to do that is with values. That it return this as an array of index and the value as it is. Yeah. Holy moly. That's right. Index iterator. Oh, because we are not returning is this. We need to return this as an object here called next. Okay. And now it calls like this. Holy F, bro. So now, oh my god. Oh my god. Mm-hmm. Mm-hmm. And then you got is a challenge 6. Create an iterator that returns each word from a string of words. Create an iterator, okay? Create an iterator that returns each word from a string of words. On the call, it is next method. Hint use regex. Then attach it is as methods to the prototype of a construction word. Hints research symbol iterator. Mm-hmm. So now that we're going to access to this, okay, as a string, and the thing that we want to return here is what? Return each word from a string of words, okay. Each word from a string of words, okay. And then here, regular expression, return a word for that. Mm-hmm. Regular expression pattern here as it is. Exactly, using regular expression to split line with different lines endings, end or line break. No, but this was discarded. An instance property. Exactly, now using this class for this. Holy moly. Well, that'll be all for this video. Yeah, that'll be all for this video. Totally, man. Holy moly, okay. Wow. Okay, I get it. Okay. Now it's like I need to is push this content here, and that is exactly. Then you have now here those iterators, or no, That was to me the most interesting challenge at all. Of all. And on the challenge 8, alright. Okay, let's go to save this. Okay. We also know how to do all of these async operations with Iterator specifically. Okay. And then here we're going to have this. documenting learning process in YouTube. Documenting learning process in YouTube. Or document. Exactly. Recording learning process in YouTube. That's right. Wait, what? Come on, man. Where is our... Yeah, where is that? Okay, you think you're funny. Getting here, your channel here. Okay, good. Here we are now. This to master it here. Wait, what the? Oh, there you got it. Exactly. Is this one? How's it going, everybody? Elvier Gonzalez here, and today we're going to take a look at the hard part of asynchronous JavaScript. Yeah, I love the way how it talk, my friend. Oh my god, yeah, I love it. I love it. Yes. Now I want to navigate to this. Link to my channel here. That's right. There you go. Okay. Cool. Now we decide to push this. They say fatal. It's not a Git repo. Get in it, bro. Okay. So you add this. Exactly. Git now push origin the upstream. I want you to make this branch. Wait, what? Oh, because exactly. Git status, git commit with a message, and say, hey, this is the git commit. Or you say git add everything here with a message here. You know what? It'll be great if we can take now this particular thing, the asynchronicity here, which is by looking at by defining here is touch callbacks.gss, and then you want to open now the callbacks here. That's right, we're here. Then go with async. Okay, and there you have is the way we promise. Mm-hmm. You have promise, iterators, callbacks, and async and await. And there you got it. And that's it. All right. Cool. Okay, okay. So, yes, that'll be all for this video. Take care. Bye bye. Jesus.